On June 25, 2026, the Democratic People's Republic of Korea conducted a series of live fire tests involving upgraded 240mm rocket launchers and tactical ballistic missiles. These evaluations signaled a technical shift in the military balance of the Korean Peninsula, centered on precision conventional strike capabilities. This rapid development is a direct result of the 2024 Treaty on Comprehensive Strategic Partnership signed between Pyongyang and Moscow. In exchange for millions of artillery shells and 15,000 combat troops deployed to the Ukrainian theater, North Korea received Russian satellite technology and advanced guidance systems. This exchange allowed the Korean People's Army to move away from its historical reliance on massed, unguided area denial fire. The June 2026 tests confirmed the integration of autonomous guidance into their frontline artillery divisions. These precision conventional assets allow Pyongyang to target critical command centers and infrastructure with high accuracy. This capability complicates the traditional deterrence logic of the United States and South Korea, as the KPA can now threaten surgical strikes that remain below the nuclear threshold. Historically, frontline North Korean artillery reached 20 to 60 kilometers. Now, the 155mm Juche 107 extends that to 65 kilometers, threatening Seoul's northern suburbs. The upgraded 240mm rocket system pushes this to 90 kilometers, encompassing the entire Seoul metropolitan area and strategic southern hubs. Most critically, this envelope reaches Pyeongtaek, the location of Camp Humphreys. As the largest overseas U.S. military base, its exposed assets are now within range of guided rocket artillery that can calculate firing solutions and displace before Allied radars coordinate a response. The increased range and precision of these systems means South Korean rear echelon staging grounds no longer benefit from geographic distance from the border. This precision extends to the ballistic missile force, specifically the KN-23. The performance of this system has been refined using data collected from combat use in Europe. In 2024, North Korean missiles deployed in Ukraine had a margin of error up to 3 kilometers. By April 2026, continuous telemetry data transfers allowed engineers to refine flight algorithms, reducing the circular error probable to a 5-meter radius. These missiles now carry a special mission warhead designed for high-accuracy strikes, targeting strategic airfields, maritime shipping ports, and power grids. The 5,000-ton destroyer Choe Hyon provides the KPA Navy with a platform for regional power projection. Larger and more complex than previous combatants, it carries sensors and vertical launch capacity for operations far beyond the coastline. With 88 vertical launch cells and phased array radars, the Choe Hyon represents a technical leap, capable of multi-directional tracking and high-density missile salvos. This combination of precision ballistic missiles and blue water naval assets forces the United States and Japan to divert surveillance resources away from other regional flashpoints to track North Korean movements in the Yellow Sea. Facing this modernized threat, South Korea has shifted its defense posture toward mass-produced uncrewed warfare. The Drone Warriors initiative trains 500,000 active-duty troops to operate drones as a secondary weapon, creating a decentralized force capable of wide-area surveillance and strike. This manpower shift is backed by a plan to procure 20,000 low-cost combat drones and 60,000 training units by the end of the decade. A key component of this arsenal is the K-Lucas, a domestically produced loitering munition designed for long-range autonomous missions. These munitions are designed to operate in swarms, hunting mobile rocket launchers and artillery positions that are hidden in the Filat north of the border. South Korea's military prioritizes these decentralized uncrewed swarms as a technical counter to the KPA's fixed artillery advantages, attempting to offset traditional artillery numbers through massed autonomous loitering munitions. The OODA loop, observe, orient, decide, and act, models military reaction time. The side completing this cycle fastest maintains the tactical initiative. North Korea's automated fire control removes human calculation. By replacing orient and decide with algorithms, the time from detection to launch is drastically compressed. This creates a volatile interface along the border, where North Korea's automated radar and fire systems face South Korea's massive autonomous drone swarms. In this dense environment, a technical error, like an accidental drone incursion or sensor malfunction, could trigger an immediate automated KPA artillery barrage. That barrage could, in turn, activate pre-programmed ROK drone swarm counterattacks, escalating the conflict before civilian leaders have time to evaluate the situation. This convergence of Russian-assisted automation and massed drone proliferation creates a hyper-militarized standoff. As autonomous systems compress the OODA loop, the time available for human diplomatic intervention during a border crisis is significantly reduced, increasing the likelihood that a technical error leads to a rapid escalation.